Hi everyone, in this video I'm going to talk about the natural logarithm, where it came from. So my problem is how to integrate 1 over x dx. If we use the standard formulas that use for integration x powers, then we would add 1 to the exponent of x and then divide by the new power, which is minus 1 plus 1. Here we have the problem, minus 1 plus 1 is 0, and here we have 0 as well. So we are going to avoid this method. We're going to take the limit of a function, integration 1 over x to the power of a, and put the limit as a approach 1, okay, dx. Here, what do we have? Limit a approaches 1 for x to minus a dx. And the standard formula tells us that the result will be x times a plus 1 divided by the new exponent, which is minus a plus 1. So here is the 1 over x function. It has a critical value when x equals 0. So to avoid this problem, I'm going to divide the integration from x equal 1, I'll take 1 as a reference point, to any other value, say x. So we need to find integration from 1 to x for 1 over x dx, although I'm a little bit conservative about finding the area from x equal 1 to x equal x, okay? But let's not complicate it right now. So if one wants to find the area from 5 to 6, he will find the area from 1 to 6 and find the area from 1 to 5, and subtract two areas and get the required area. So we earlier found that this equals to limit a approaches 1, okay, for x to power minus a plus 1 over minus a plus 1. Now we substitute the limits of this function, which are 1 and x. Okay, so we get x to power minus a plus 1 over minus a plus 1. You can put any other variable, tau or y, okay, if you find this not really acceptable. Minus the lower limit, 1 to minus a plus 1 over minus a plus 1. Okay, now 1 to this power is always 1. 1 to any power is always 1. So this value is 1. So this would be equals to x to minus a plus 1 over minus a plus 1. Here we have minus 1, this one, okay? And don't forget the limit when a approaches 1. Okay, now instead of writing minus a plus 1 when a approaches 1, so minus a plus 1 will approach 0, we will define a new variable, let's call it b. Okay, b equals to minus a plus 1, and we take the limit, okay, limit b approaches 0 instead, for x to b minus 1 over b. So b equals to minus a plus 1 for when a approaches 1, minus 1 plus 1 approaches 0, so that's what we wrote over here. Okay, now I'm going to prove you that this function, limit b approaches 0, x to b minus 1 over b, is equivalent to the common, well-known logarithmic function. I'm talking about natural logarithmic, of course. Log x to e, or just ln x. Okay, so I'm going to prove that by substituting some numerical values. I've put x5, so we have natural logarithm of 5 is 1.609. Also, I've put x equals 5 in this formula. Now x, which is 5 raised to a very small number, minus 1 divided by the same very small number, and the result was just same as natural logarithm of 5. Now if you study the characteristics of this function, okay, you will find that it behaves just like a logarithmic function. Okay, say this equals to log x for some base that we don't know what it is. So let's say it's c. And now we find the value of c. So this equation must be true for all values of x, but we will use a special value of x to simplify the solution that will find c. Okay, we know that log 2 of 2 equals 1. Also, the log 10 of 10 is 1 as well. So I will substitute x as c, okay, so that log c to c would be 1. Okay, we have, so limit b approaches 0, x, I'll put it as c to b minus 1 over b equals log c to the base c, which is 1. Okay, so we have b equals c to b minus 1, which leads us to c equals b plus 1 raised to a power of 1 over b. Okay, now to find the value of c, I'll use the calculator to show you it. Okay, now we have 1 plus very small number, which is b, 0.001 raised to 1 over the same very small number, which is 0.001. The result is this. Now this is a constant called e. Okay, so it's appeared that c is equal to 2.7, 1828, 1828, and so on, which equals to e. Okay, so we find out that integration of 1 over x dx, okay, is equals to log x to the base e. We can call this the natural logarithm of x. Thanks for watching.